Hello, on this recording we're going to be going into how to code Java code from the SQA pseudo language that you would get in a theory exam. So how to put it into practical use in the Java language using Netbeans IDE. So to start off with, I'm just going to introduce you to a couple of concepts inside Netbeans before we actually go into converting an example from pseudocode that you hope you'll understand and into actually Java machine language. Or programming language. Machine language would be compared to. Okay, so to start off, you would want to start a new project. So you can click on this little icon here where my mouse is over now, or you would go File, New Project, or Control-Shift-N. So we're going to start the new project. So we're going to choose a Java application, and we are going to give it a name, example. It's important that you choose a correct folder location, which you can do by pressing browse. I am not going to do that though because I am in the correct location at the moment. And you are going to create a main class. I'm not going to go into details of this now, but the first one before it is a package. I like calling my package before the dot is the package name. I like calling my packages Pac-Man. It's funny. And I call my main class main, or UE because it's a user interface as well, but irrelevant. I'm going to call it main right now. So pacman.main, and it will create me a project with a main class in it. I'm not going to go into too much details of the idea of a package and a class. So we've got a project, a package, a class, and I will be mentioning those briefly later when we start using other people's packages and other people's classes. These comments I'm just deleting. They are comments, so to comment in Netbeans or in Java, it's // for a single line comment. For a multi-line comment, it's /*, and then everything in between the /* and */ will be a comment, meaning only the programmer will see it. It is not executed. Now, public class main means that we're in, first package Pac-Man just means we are part of that package. We're inside the class main, and we're inside the public static void main. What that means is when I press the play button here, or when I execute this program, if I distribute it, it means what is in here is where it will start from, is what will run. And we're only going to deal with the main method right now. We're not going to deal with object orientation or anything like that. We're just going to deal with algorithms and concepts on those lines. So the first thing we are going to get into is the idea of a variable and how to create a variable. Now, every single variable, you have two steps. Step one, step one is to declare the variable. Now, to declare the variable, you give it the following structure. It goes data type, and then you give it space, and then a logical name. So in this case, we have a different one. I'm going to go through a couple. I'm going to go int num, semicolon. So every single line in Java is ended with a semicolon to say that the statement has been completed. Enters are not end of statements. Semicolon is an end of a statement because you might have statements that go over multiple lines. So enters is not end of a statement. Semicolon is an end of a statement. So int is one data type. Int is integer, meaning it is whole numbers. So remember, int is a data type. It highlights data types in blue. Another data type is character. I'm just going to call this one ch. Sorry. Okay, so character will store an individual character, a single character. A different data type that you might need to know of is boolean. I'm just going to call this one boo. And last one, let's just go for float. Now, the idea of float is a float will take real numbers, meaning that they will take decimal places, whereas your integer will only take whole numbers. A float will take decimal places. So here we've declared variables, and the next thing is the concept of initializing. Now, initializing is very important. That's actually assigning a value to it. So I'm going to, before I go into initializing, I'm just going to quickly mention what we've done here. When I go int num, what I'm doing is I'm actually creating a pointer to a variable. So the actual space doesn't exist yet. So let's say if this is my RAM. So for example, if I wanted to store a bit of information, I might want to store it in this portion over here. A pointer, I'll just say num, so easy reference, would then point to that location over there. I'll get into more details of that just now. So int num is literally just creating a pointer, and then it would point to an address that it would point to. In the RAM it would be. So when we refer to num, it would point to an address. Now the address in RAM would be a hexadecimal number. In this case, I'm going to do my address so like for example E1 to J1 would then refer to E1 to J1 memory address location. So I'm not going to go into much details of that. And also remember our RAM stores in an operating system in a binary. So let's just set up our binary sort of structure here: 32, 64, 128, and 256 if we need it. Okay, so 8 bits is over here, and I'm going to assume my variables, well, for an integer takes I think 2 bytes, so I have to do up to 8 different numbers here. I'm not going to do 16 different bits. I'm only going to do 8. 8 is up to here. I'm not going to do 16. And string takes unlimited, character takes quite a lot. I think if it's a ASCII character it takes 8 bits, I think. Boolean actually takes 8 bits, but it's got floating things in there. Float will take up a lot larger, but we're just going to assume that all of them take up 8 bits of memory location, just for the sake of this demonstration. So we've created pointers to num, we've created a pointer to ch, we've created a pointer to boo, and we've created a pointer to num2. Now, you'll notice that all of these are highlighted blue. I'm going to go through one other data type, which is not actually really a data type, and I'm going to call it S. And this is I'm going to call it text, because string stores a text, and you'll notice it's not highlighted blue because technically it's not actually a individual data type. It is actually an array of characters. So for example, if we looked at the word, so in this case text, it will be a pointer. And if we were to store, we might store multiple address locations in there. So in the example I'm going to go through, I want to make the string only of a size 3, so it would have 3 addresses within it. So I'm calling it something different because it's not actually a data type, but we can use it like a data type because it's very commonly done. So we've got 5 different variables there, and now we're going to look at initializing them. Okay, so num is equal to 5, easy enough. Now literally what you'd be doing then is you'd be creating 5, so it would be 0, 0, 0, 0, 0, 1, 0, 1. Okay, so that is the number 5, and then my num would point to the address F2 to M2, which means that only when you actually give it a value does it actually reserve the space in RAM. It doesn't reserve the space in RAM until you've initialized it. Declaring it does only creates the pointer. It does not actually put it in. It's an important distinction to make because you can't use a variable if it doesn't exist yet. So in other words, if you've declared it, doesn't mean you can use it. You have to declare it and initialize it before you can use it. Otherwise, it doesn't exist. It's literally just a blank pointer that doesn't do anything, so it doesn't know how to deal with it. Alright, so character we're going to initialize. Now here we're starting to introduce the concept of literals. Like 5 is a physical number that we assign to it here, but here we have to determine that it's a character. So we enclose it in single, that's not a single inverted comma, I've got to find the keyboards in this country are slightly different to our keyboards in South Africa. So I'm going to talk about storing a character, so let's just say store the character A. So now you'll see a character is enclosed with single quotation marks showing that what is in between this is a character. So now remember, it knows that this is a character. This pointer tells me that it is a character. So if I go here and I want to store this in this location, what is the character A? And interestingly enough, if you go into Word, I wonder if I've got an on-screen keyboard that I can quickly pop up. I don't know if it'll work on the on-screen keyboard, but I've got an on-screen keyboard here. So if I go, is it a numpad? That's annoying. But yeah, so if I press Alt, the on-screen keyboard is not going to allow me to do it. It's annoying. Unless I can maybe turn on the numeric keyboard. Okay, so if I press Alt and I type in 065, enter, you'll see there it should pop up with a character on. If I press it on the keyboard, it will work. That's not going to show it on the screen, is it? It's annoying. Okay, Okay, so it shows you on the screen. So I'm going to use the keyboard down here, and I'm going to work with it there. It's a bit annoying, but it will work. Okay, so if my cursor's over there, I press Alt, I press 0. You can't see it on the keyboard. I'm pressing 0 and 65. So annoying. Okay, I can't hold down Alt on the. That's annoying. Okay, I can't do it on the on-screen keyboard. So sorry, you're not going to see it on here. But trust me when I tell you, I'm pressing Alt 065. And you'll see the capital A comes up. The reason why is because the ASCII character code for A is 65. So for example, if I just go to normal so every single character code has a character code through it. If you're talking about Unicode, if you're talking about hexadecimal, here we go. That's a nice way of showing it. So A in hexadecimal, capital A is 041, small a is 061. So 061 equals, okay. Anyway, there is a numerical value assigned to it. So let's just assume 65 in this case, or whatever, but there's a numerical value assigned to the character A. So what we're going to do is with ASCII code, we are going to go and we are going to put in the numerical value for it. So in our RAM, what would be stored would be 65, so 01000001, and then this would be referring to F3 to M3. And in real life, it would be something like a more AFB12C or whatever. It would be a hexadecimal code for the memory location address that it would be stored at. Okay, so character has been stored, and now we would be working with the boolean. So boolean, so boo, I'm going to set it to be true, and the same thing. Technically, it does create 8 bits because it comes up with these blank space holders, and the last bit would tell me whether it's true or false. So 1 for true, 0 for false, and this would be stored in F4 to M4. So we've created a boolean storage location. In num2, this is a float. So num2 and a float can store something like 2.4. It's not like it. Now, with a float number, double to float. Okay, so this is actually working with a double format. We can cast it to a float. I don't want to go into too much details of that with regards to casting. So let's just change the data type and let's work with doubles rather. Okay, so we're going to work with num2 as a double. A double and a float are very similar. Double can store an extremely large number. It can handle decimal places and up to a very large size. There's also an item called single as well, which is just a smaller size of a double. But yeah, they're real numbers that you are working with. Okay, so you work with real numbers on that regard. Okay, now we've initialized our 2.4. Now how that works, yeah, it goes into other sort of storage areas. I'm not going to go into details of decimal places on this video, but yeah. Okay, so that would be stored from F5 to M5. Now let's go into the idea of a string. So our text, again, very similarly to how our characters had to be enclosed in single inverted commas, text needs to be enclosed in double inverted commas. So in this case, I'm just going to say that dad. The reason why is dad would be quite easy to work out. If A is 65, D would be A, B, C, D. So it would be 65, 66, 67, 68. So it would be 68. So D would be 68. So we'll store 0, 1, 0, 0, 0, 1, 0, 0, and that would be a D. A we already had here in the character, so let's just copy and paste that. And then D would also be the same thing again. Okay, so we've got there dad stored, and our text string would actually refer to it. It's a list of array references, sorry, list of characters that we have. So this is now from F6 to M6, and we'll see how clever Excel is to see if it will think about incrementing. Nope, only the last one. It's a bit annoying. Okay. So it would take us memory addresses to store the variable dad. Now, this is all good and well. We are going through the concept of declaring variables and initializing them. But now we've got to go through the concept of, I'm going to make it a little bit easier. You can do both in the same step. So logical name, and you can initialize it. So I'm going to delete this here, and I'm just going to create integer numbers equal to 5, and you guys get the rest. So you can do both the declaration and the initialization in the same step. But you must realize that there are different concepts, and there are times where you might need to declare it before you can initialize it, and that's perfectly fine. But usually it's good to have it just to initialize it when you get it, like you saw in the code that we were going through further. Okay, so that's variables introduced to. Now we're going to get to the idea of getting information to the display and getting information out from the display. Java can handle a lot of GUI components, and we can use other classes to work with GUI components. But in 5, we are going to be dealing predominantly just with the command line. So, step 1, getting information out to the command line. SOUT tab. So now, SOUT tab, so SOUT tab, opens up system, which remember I told you I'll get back to packages later on. System is a package of the Java class, out is a class of the Java class, print line is a method. Now the method will print to our output here, meaning that it's going to print a line to the output there. So we're going to do the tradition of everything. The first time you operate with a coding language, you should create a print out to the screen to show that you can communicate with the screen. That behind the scenes is quite complicated. Alright, so when I press play, hello world, it would run onto the screen. It would show it there. So I can hide the output, show the output, and this is running to the command line. So we can get an output to the screen. Now interestingly enough, if I had a string text is equal to bacon, let's say, I could also append the text to it. So if I then said text, I'm going to use the character \n. Now on the \n, when I press play here, you'll see the hello world, bacon is on the next line. So \n represents a character that would go into a new line. So we've done so far hello, hello world, and we have now entered text beyond that. Now I'm going to delete that for now because that's just a silly example. Oopsie. Can't see, but my dog is saying hello to me. Now, so that is to get command out, but what if we want to get input from? Now, it's quite complicated, but when you're getting a stream of input, each character is pressed and it is worked through. So like here, we used someone else's class, system.out, so the out class to get it to the command line. We're going to use a class that will help us read in from the keyboard and to scan through the input that is going through there. And that class is called a scanner. Now you'll see that I use control spacebar, and the reason why is it also requires to import it, because if every single possible class that is out there is in every project, the project will just be massive because there's tons of stuff out there. So you can import only what you need. So you'll see here, if I go scanner, it will import java.util.scanner, meaning that now I've imported a class that exists outside of mine into it. So I should use control spacebar. You can also import it yourself and just put a star, which means it would import all java.util classes. Again, Java project, util package, in this case scanner was the class that was working in. I don't like using start though, because then it would import a lot more than I'm not using, so I just use control spacebar, enter in Netbeans, this nice shortcut. It will then import it to the project so that we can use it. Okay, so we are now going to create a scanner. I'm going to call it scanner in because it's scanning the input, and we are going to say it is equal to a new scanner. You guys can predominantly regurgitate this, but just realize you're creating an object of a scanner class which is created by somebody else that we can use. And object orientation is very successful because we can create something and then reuse it again and again and again. And the scanner is one of those classes that is released with a Java that you can use and you use quite extensively. Okay, so scanner we're going to be scanning an input stream, and the input stream, like we got system.out, the input stream that we are going to read from is system.in. Now system.in is the actual command line that would get it from. And without creating the scanner, I could potentially go, I haven't tried this, so this might fail, but I could go system.in.read. And what that would do is you'll see it will read, and it shows me that it's a read method, and it returns a integer. So I've stored this as a character, but if I go there and I store this as an int b, it's giving me a read underline. It's just, so when you move your mouse over it, it'll tell you what the read underline is. Okay, this is talking about exceptions. I don't particularly want to go through an idea of an exception yet. And I'm going to handle it, just more to show you the point of what I'm trying to get at here. So I'm going to delete, I'm going to comment out the scanner. So we're just going to say hello world, and now we're going to be getting an input from the keyboard. And I'm going to start the int b, and I'm going to say plus b. So we're going to display what is read from the keyboard. So hello world, let's just change this. Let's say enter a character. I am then going to, this is commented out so the computer ignores it. It goes down to the next line, it goes to the try catch. Don't worry too much about the try catch. The try catch is just handling if something is completely pear-shaped, what are we going to do? So this is what we're going to do if it goes pear-shaped. So here would be a comment. It's gone pear-shaped is what would be inside there. You don't need to worry about try catches, catching error conditions and things like that. That's higher, advanced higher. This is just more the concept of, I want to show you that system.in is to read from the keyboard and why we have to use a scanner. That's the purpose of this, not that. So if I want to enter the character, I'm going to enter the character A, enter, and you'll see A is represented by the character number 97. We've got it quite far off. So let's try capital A, because capital A, enter, there we go. Capital A is the character 65. So you'll see there that the capital A is the value 65. So that is an integer, and that would only read in an individual character. And as an integer, you can cast it and we can convert it into it. It becomes a mission. If we want more than just one character, we've got to work with that. So what we do is we tell our scanner to have to handle all of that stuff that I was doing there. We don't need to worry about, because there's a lovely scanner class that was created. I can now ignore all these other imports that we created, and we can just import the scanner, and the scanner will deal with everything I was just coding. That is why you need to know the scanner. So use your control spacebar, practice this line. This line will get you to allow you to communicate with the command line. So now I can ask the user, enter text. Now I say enter text because if I go string text, so let me actually show you first. If I go scn and I use a method called next line, and this is going to read the whole entire line, but you'll notice there it shows me that it's going to have a method and it's going to return a string, which is a data, acts like a data type of text. So that is what it's going to return. Now as it stands, it will work, but I can't refer to it. It returns me a string, but I don't do anything with it. So what we need to do is we need to declare, so we create a string variable called text, and we need to put, how you spell string, you need to put what is returned from that scanner into the text. And now we can go start, and we can say user entered, and we can then full colon space, we can append, which is now adding the characters to the end of those characters, putting them into a single string, sending them through to the command line. Right, so we're going to put through the text over there, Control S, and we are going to press play. Now that I've done it, enter text, hello, user entered text, entered hello. There we go. So we're storing what the user has entered so we can use it in the future. Now what if the user entered a number? I suggest you do still use your .next line, but now what you would do is you can convert it, because now if I use it into number 1, and if I duplicate it, let me just take this out of here, put it on the top. Now if we ask the user to enter in 2 numbers, so get to the 2, so now we're asking the user to input 2 numbers, and we wrote now here in my output, I'm going to make more of a detailed output now. I'm going to say user num, so let's say text. Nice little shortcut here. I want to rename this variable from text into something more appropriate. I can press Control R and then I can call it num1. And then same thing here, Control R, num1. It will change all the, sorry, that should be num2. It will change all the references to it. Plus space plus num2 is plus the equal sign is equal to plus what is it? Answer. So the answer would be num1 plus num2. Now what you'll see here is I'm going to run this and show you what happens. If I enter number 1 50 and enter number 2 30, we know the answer is 80. But 50 plus 30 is 5030, and the reason why is because it's the character 50 and 30. So it's just going to append it. If you take a string plus a string, it appends it, which is actually quite complicated that Java does for you, but it is quite a handy tool to have. So, how do we convert? Now, there is a way of getting next int, but when you do that, it battles to continue to use the scanner. So I'm going to look at the concept of converting a numerical value from text to a numerical value. So what I'm going to do now is I'm going to call this variable, so Control R. We're going to call it snum1 because this is the string version of num1, and now I'm going to create an integer num1. And what we can do is we can go integer. Now this is the, let me finish putting it up before I go into it, but integer is not like int. Int is a data type, small I, small n, small t. Capital letters represent a class. So integer is the class integer, and then I'm using a method called parseInt, where I'll send through the snum. So basically it'll take in what the string is. As it goes across, it's going to change it into an integer, then store it into num1. And I'm going to do the same thing for my num2. I'm going to now call this one snum2. I'm going to call this num2. So now, here, if I do the following, and I refer to, I can actually refer to either or, it really doesn't really matter. It should be a small n. That's something I haven't made a note of. Capital N does not equal a small n. They are different. Java is case sensitive, meaning that it will not pick up 2 as the same. So now when I press play, you'll see there that enter number 1, so let's use 50, 60, so 50 plus 50 is equal to 100. So you see here I converted snum1 into parseInt, so it converted the same number twice, which is pretty stupid of me. So 60 plus 40 is 100. Okay. So it does work now. But now, what if I had, for example, 10.5? I can't convert integer is a whole number, so it cannot convert decimal places into an integer. So I can create it as being a float. So if I create it as a float, I would use float.parseFloat. So float.parseFloat. So let's do the same here. Float. And then I'll just use float.parseFloat. So capital F for the class, float.parseFloat. And then now you'll see I can use, say, 10.5, so 1.5 and 3.62, and you'll see that 1.5 plus 3.62 is equal to 5.12. The same thing, I haven't actually tried a double before, so let's try a double. So double and double pass double. Let's just copy and paste that. Copy, paste. Let's just also call this a double. So the same sort of thing works for double. And if we go play into number 1, 20.63, 20.2, that's 40.263. So now doubles and floats can deal with this, or deal with real numbers. In SQA syntax, they talk about real, which is the same thing. Okay, so we've learned the idea of getting input from the user. We learned how to get text from the user and how to convert that text into, or convert that string of characters into a numerical value of either a real type or an integer type. Okay, so last step before I end this video, and the next video I'll do on the converting the things directly, and we are 31 minutes into it, so just as well. What we're going to do now is we're going to learn the concept of loops, loops and then if statements. So we've got two things to do. Yeah. So loop. If you want to create a loop where it's a known number of times, you press 4 tab. Now you'll see there, if I start I, you'll see there I is equal to 0, while I is less than 10. You'll see what will happen is it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that loops 10 times, because, sorry, 0, 5, 6, 7, 8, 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, sorry, 9. So 9, because 10 is no longer less than 10. So 0 till 9 is 10 times that it will loop. And just to go through the for condition, this is where it starts. We declare a counter variable. We would say, well, I is less than 10, and we would go I plus plus. If you take a look at your code that I gave you, that would be the same in the pseudocode as saying for counter from 1 to 10. It's the same as in Java doing this. Okay. Now this is the condition. I plus plus is a shortcut. That is the equivalent of saying I is equal to I plus 1. I plus plus does the exact same thing. It's the same concept as if I said I plus equals 2. It's the same as saying I is equal to I plus 2. So there's a couple of little shortcuts that Java gives you to make your life easier. Okay, so that is a for loop. The other type of loop is a while loop, so I can go int I is equal to 0. I is basically a common variable name for a counter. So if you're ever doing a counter where you're incrementing down, instead of saying counter all the time, I is the programming way of, we know I is counter. If you tell me I, so I go, okay, it's a counting variable. And then J will also be a counting variable and so forth. It's like having X and Y and Z. It's mathematical terms for a variable. It's now I is a counter. It's what we use for counters, and instead of saying counter every single time. So now I'm going to say while I is less than 10, and this is actually the equivalent. It's a bit of a silly one, I plus plus, but this right here is the equivalent of the for loop that we had. But this might, for example, we want to loop until the user chooses to exit, so we might go string choice is equal to blank semicolon, and then we could say while choice. Now this is an interesting thing, I haven't gone through this before, but to do comparatives with numerical values. So let's say let's go integer. Let's do an integer. I don't think you need to learn how to compare strings. I'm not going to do that. I'm 99.9% sure. Okay, so we're going to say int c, meaning int choice, is equal to -1 semicolon while choice does not equal to 0. So now this is going to loop until choice is equal to 0. Now to get a command line print, remember you would create a scanner, so I would create that at the top because we know we're going to use it, so scanner scn, and we're going to call this one new scanner, and we are going to scan from the input stream. We're going to scan from the input stream system dot in. Okay, and now for the choice, I'm going to print out to the user enter 0 to exit, comma, else press 1 to say hello again. Pretty stupid, but yeah. So now what we're going to do is we're going to go choice. What I was showing earlier, I'm going to do on one line now because I'm lazy, is equal to integer.parseInt and sen.next. Cool. So now I've done the exact same thing as we were doing earlier. I took in the reading income thing, which is a string, and I've immediately converted it into an integer and stored it into the choice. Now, if the choice is not equal to 0, it will say hello. If it is equal to 0, it will exit. So start, exited. So this is a stupid little menu system that I've created here, where when we start off the choice as being -1, we'll say hello because -1 is not equal to 0, so it will enter the loop. Not equal to is this. In other languages, they might represent it like this. In math, they put a line through the 0, and that's how it's represented in text. But exclamation mark equals is how it's represented in Java and I think C++ and I think a couple other languages. Microsoft-based languages use not equals like that, so SQL uses it like that, but in this case it's not equals to, it's represented like that. So now I'm going to say we run this program to show you what it does. So line 1, it says there enter 0 to exit or press 1 to say hello again. So if I press 1, it will say hello. If I press 0, it will exit. Okay, so this would continue looping. So a while loop is an unknown number of times. You use a for loop when you know the number of times that's going. Now there is also a repeat until. I've actually don't use that in Java much because I always kind of feel you can, there might be a do until actually. Yeah. You could do a do while, so your condition will happen afterwards, which means it will happen at least once. So do while, I could arguably, it would be easier to do that because it means it would have to at least execute once. Meaning it will check the condition at the end of it, not at the beginning of it, which is basically the exact same thing. It's just how you want your order to occur. In other words, before you enter the loop, do you want to check or do you want it to at least occur once, no matter what? And in which case, I don't even have to initialize a choice yet, because we know that it will go into here and initialize it at some point. So we're okay with that. Alright. So same sort of thing. Next thing is a if statement, because now we're saying hello even if they press the number somewhere. So if we could say hello, and we could then say to say goodbye, else mistake. Okay, so now we want to put an if statement. So if tab, it just comes up with a condition for us, it just says if true. So we say if choice is equal to 1, so to compare it is equal, to assign a value it is a single equals, to compare it is a double equals. So now I'm just going to say, so if choice is equal to 1, we want it to say hello. If choice was 2, I don't like this loop that I've done. The reason why is we're doing a check before we even know that it's what the user's done. So I'm actually going to convert it back here. And I'm going to ask the user prior to entering the loop what they want to do. So what I'm doing is I do have to now ask them twice. So basically now I'm asking them first what they want to do before I enter the loop, and then from there we'll work with that. Okay, so now else if choice is equal to 2, then, so basically it's only if this is false will it go into this, then it will check if the choice is 2, and now start, this was by, and then else start mistake. So what we've got is we've got different conditions here. Our first condition, if choice is equal to 1, it will check if it should be hello, else if choice is equal to 2, it will be by. None of those is correct, it will go mistake. So let's run it, let's check it. I've gone through a lot on this. I will recover these concepts as we do the other ones, more simple examples. but this is just going through the basics or the syntax that we will need to use. Okay, so if I press 1, it'll say hello. If I press 2, it'll say bye. If I press 3, it'll say mistake. If I press 0, it will exit. So it means that we've created a menu based on allowing the user to type in whatever they wanted to as they exited. Okay, this is the end of this video. 40 minutes, it's a full lesson. Yeah, hope this video has helped you, and you can refer back to it if you not understanding anything. Goodbye, enjoy your day. Video 2 to follow. Goodbye.